Welcome to qnawire.
So here in this problem it is given that an ideal gas goes through the process as shown in this figure, and the process A to B is an adiabatic process and the process B to C is isobaric process with 100 kilojoule of energy is entering into the system by heat, and the process CD is isothermal process, and the process DA is isobaric with Q is equals to 150 kilojoule. It is leaving out from the system, and we have to calculate the difference in the internal energy for the process AB. So we have to calculate delta AB. This thing we have to calculate. Now to calculate this, first we'll be using the first law of thermodynamics, according to which we can say that the internal energy for the whole cycle will be equals to 0. So it means internal energy for the process AB plus internal energy for the process BC plus internal energy for the process CD plus internal energy for the process its dA will be equals to 0. Now the internal energy for in case of CD will be 0 because it's an isothermal process, and for isothermal process the change in internal energy will be 0. From here we can write that the change in internal energy for AB will be equals to minus of change in internal energy for BC plus change in internal energy for dA. Now we know that the change in internal energy is equals to work plus heat. So we can write this thing, we can use this formula here. So work in case of BC plus heat in case of BC plus its work in case of dA plus heat in case of dA. So we're going to now plug the value of work for BC, and we know that the work is equals to minus P delta V for isobaric process. So we can use this formula here. So minus, it will be pressure for at B. That means I'm writing the work for this process BC. So if you consider the pressure here, it will be PB is equals to PC because the pressure at B and C same, or we can write directly PB. So I'm using this here, and times the delta V of BC plus Q of BC. So plus similarly the work for the process dA will be PD times delta V of dA plus Q of dA. So we're going to simplify this and we'll get minus of QBC. Actually it should be minus sign here because the work is given as minus P delta V. So we have to include minus sign also here. Now we're going to simplify this and we'll get minus of QBC plus QDA plus PB delta V of BC plus PD, it's delta V of dA. Now we'll be plugging all the values in this formula to calculate the value of change in internal energy for the process AB. So it will be equals to minus sign. QBC is the heat added in the process BC, and that is 100 kilojoule. So we have to write 100 kilojoule here plus QDA is this heat, but as the heat is removing from the system we have to take minus 150 here. So it will be minus 150 kilojoule. Plus the pressure at B point is, it is 3 atm. Now if we convert atm into kilopascal, we'll get 3 into 1.01, 3 into 10 to the power 5, it is atm. Now if we convert this into kilopascal, we'll get 3 into 1.013 into 10 to the power 2 kilopascal. So it will be, we can plug the value here for PB, that is 3 into 1.013 into 10 to the power 2 kilopascal times volume at point C minus volume at point B, that is 0.4 meter cube minus 0.09 meter cube, plus the pressure at point D is 1 atm. That means if you convert this thing into kilopascal, we'll get 1.013 into 10 to the power 2 kilopascal times the change in volume for dA, that means volume at point D minus volume at point A. Sorry, volume at point A we have to consider first because it's V final minus V initial. So final volume is VA, that means 0.2 meter cube minus it's 1.2 meter cube. So we're going to simplify this and we'll get the result as 42.9 kilojoule. So we can conclude that the change in internal energy for the process AB is equals to 42.9 kilojoule. So this is the final answer. I hope you got the problem. Thank you.